Let's today talk about what's easy to do with LLMs, what's hard to do with LLMs, and where that boundary is for generative AI. So this is a recent talk I gave to one of our customers. This is September 2024. And what I want to do is I'm going to give a version of the talk. This is for YouTube, so I'm going to leave out some of the introduction. I'm going to leave out some of the jokes. I'm also going to talk a little faster, so it's not the same way as if I was there in person. But what I want to do is walk through first the basics of how to use large language models, what Retrieval Augmented Generation is. And then I want to apply this to two different stories. We're going to take the law firm of Dewey, Cheetham, and Howe, and then a hypothetical company called Frosty. And these will help us explain how folks are using generative AI today. What are the limits? What does it take to actually develop a generative AI application? Now, I'm going to start my story up really up high here. So up about 30,000 feet in the air, a couple of years ago, flight attendant was bringing that meal cart up and down the aisle, smashed a knee of a passenger. That passenger went on to file a lawsuit against the company. A couple years later, lawyers filling it out. It's a holiday weekend coming up. He's working on that brief response. He decides to take advantage of ChatGPT to help him proof out his brief. Along the way, ChatGPT finds some cases that were unpublished, right? Great legal research tool, finding things around there. And he was like, hey, maybe it's finding things that I wasn't able to like that. What he didn't realize, though, that was ChatGPT was quite happy to make up those cases. And in fact, what happened is he was actually admonished by the bar for doing this. And lawyers all around know that they cannot trust tools like ChatGPT when they're doing legal research because these models can make up information. Now, I often demonstrate this with this type of example. I typically have a Streamlit application, but this is a very factual-based question. How many vehicles will Rivian manufacture in Normal, Illinois? This is, of course, meaningful to me. I live in central Illinois. I live near Rivian. It's a very topical question. And when I ask this question, I ask it to two different large language models. I have the Google Gemma model here and the Rekaflesh model as well. And when I ask it, you'll see that I get two different answers here in response. And is that strange? Should we expect it? I think most of you understand at this point that two different manufacturers, two different methods for training these models are probably going to lead to two different results. Now, what I want to make sure you all understand is the way these models work. And the way these models work is they try to predict the next word or token. And what they're doing is trying to predict that on a statistical basis. What's the most likely thing? And so in the process, what they're doing is not worried about truth and false. They're really trying to tell what the most cohesive, coherent story is for these. And so if you ask a model what the capital of Mars is, it doesn't know that that's fictional. It's going to try to complete that story, and it's going to give you an answer. Same thing. If you try to ask it to do some math, well, it doesn't know it's a calculator. It's seen lots of math examples before, so it's just going to complete the math story. In this case, it looks like it's read too many release notes, not actually enough math for how to do it, and it gets it wrong. Now, it's important, especially for companies, to recognize that there's risks that come along with these generative AI when they're making mistakes. So this is a very wide-known case. Air Canada's chatbot went off the rails a little bit, and when they went and tried to enforce it, the government said, hey, we're going to treat this chatbot just like one of your employees, one of your agents. You're responsible for what those agents, employees say. You're going to be responsible for what this model says. So this helps you understand why so many enterprises are very careful about putting out generative AI. You see so many Gen AI committees around this. So we've got a problem here, right? We've got these hallucinations. Don't worry. Our friends in academia were busy working on this, came up with a solution. It has a mouthful of name, Retrieval Augmented Generation. It's often shortened and called RAG for short. And the idea of RAG was, instead of the model just sitting by itself and trying to answer the question, we're going to surround the model with context. We're going to ground it with information so it uses that information in answering the question. So if you look at this diagram, what happens is when we bring the large language model a question, we don't just bring it directly to it. Instead, we first take that question and we go out and search and look for, is there relevant information that's related to this question? If so, let's collect that information together and we'll bring that to the large language model. So that way, our final answer is grounded by the large language model. Now, let me walk you through an example of this. I'm going to ground this with 10K forms. These are widely used in the public in the US. For all public companies have to file these. You can trust that they're factual. Now, we're going to stick to the same question we're going to ask. And you'll see here, I've got my Streamlit app running. We have the question, how many vehicles do you manufacture in normal? And now we have an answer. But what's the valuable thing about these RAG use cases is we can see the context. I can see exactly what's the document that this answer came from. We have a citation. We can go look it up, a nice source. And so this is what makes RAG powerful, this ability to retrieve and give us a coherent way of understanding the answer is why this is the #1 most popular generative AI application of large language models. Pretty much every company at this point has some types of RAG use cases running. Now, I did this in a speech. I like to have fun, so I made this hypothetical law firm of Dewey, Cheetham, and Howe, where what they want to do is reduce the amount of time their staff spends doing legal research. They've seen these innovations. Can we apply it to legal research? Now, a friend of mine went and worked at Dewey, Cheetham, and Howe, and when he first started off, he was like, well, I've seen these models. I've seen GPT-4. I know it can pass the bar exam. Granted, this is the multiple choice bar exam, but it's got to know something about the law. Why don't I just wire it up directly and have all of our lawyers use that as an aid for legal research? And so my buddy set that up. But like a couple days later, another lawyer came knocking on his door and saying, hey, I have a problem. I asked for this online dating services in Connecticut. And my buddy's like, well, what's the problem? It looks like you got a result, Connecticut general statute. But this is when the lawyer pointed out, well, I actually looked it up. There is no statute. This was entirely hallucinated. Uh-oh. And so this is when my buddy realized, oh boy, I should probably go check out that RAG approach that we talked about. Go grab all the different legal literature there is, ground it, so that way the lawyers have actual facts and we could link it to courts and citations. Now, as he was doing this, he figured out that there was actually legal services out there. LexisNexis, for example, offers a way to get hallucination-free linked legal citations, right? Using that RAG approach that we talked about. So he's like, okay, I'm going to wire this up for the attorneys. He did. And a couple days later, an attorney comes in and says, hey, I'm not, this result here doesn't seem to make sense to me. My buddy's like, well, there's a case citation there. It's based on a real case, right? That case exists. And the lawyer's like, yeah, the case exists, but it's confusing two different concepts here of the equity cleanup doctrine and the doctrine of clean hands. Equity cleanup is about when you have many different equitable claims. Instead of spreading that over multiple cases, a court can consolidate those in one case. While clean hands is really about the conduct coming into a case. If you're, for example, a hypothetical rock star like Diddy, and you might have coerced somebody and used fraud and different techniques like that to get them to sign a contract, you can't expect a court later to come in and enforce that contract if you've come in with unclean hands like that. So as you can see, the words are kind of similar, but they're very two different legal concepts here that the model didn't recognize and wasn't able to separate. And it wasn't just that. Another of the lawyers walked in and said, hey, I had asked it to give me these notable opinions by Judge Luther Wilgarten. And of course, my buddy again was confused, like, hey, isn't that case exist? And yeah, the case exists. But the thing is I was kind of joking around. Luther Wilgarten isn't a real judge. It's a fictional judge that's in some law reviews that all lawyers know is an inside joke. And if you read the rest of this, it doesn't make any sense. And I asked for a notable opinion. This wasn't notable. It was unpublished. Now, I gave a couple of examples. You can find a lot more in this paper out of Stanford that looked at how much these models hallucinate using real questions, the typical questions you'd get in legal research, and they had it analyzed by folks that actually knew about the law. And this kind of leads me to one of the limits that you'll see with tools like Retrieval Augmented Generation, where it's really good at retrieving information and where it's all true, where it's authoritative, applicable. What happens is, and the legal research is a great example of this, is sometimes all these things are very contested and it gets really hard to separate it. So in the legal context, for example, think about somebody getting injured out on a boat. There's a lot of different specialties. It might be a tort law, it might be criminal law, it might be maritime. A legal researcher has to sort through, figure out which one of these, or maybe multiple of these, are applicable. You have different jurisdictions in the United States. You have the federal court system, the state, local, there's regulatory systems. Beyond that, you have different authorities. We all have the Supreme Court that we know about, but every state has a Supreme Court. There's also Court of Appeals that often write opinions that are very influential. But in New York, the Court of Appeals is called the Supreme Court. And then you have trial courts, law reviews. You have law reviews from Harvard, you have law reviews from other law schools. All of these have to be taken into account, and you have to weave these together when you're doing legal research. You also have to take into consideration time. When cases are overturned, that's a big deal in law. You need to know at what point in time this was. And so for me, all of this just reminded me that how difficult legal research is. And here I'm talking legal research, but I think this applies to a lot of other fields out there where we just assume it's just simply retrieving facts. But what we find out that you really have to have a lot of knowledge to be able to weave everything in and out and separate all the things that are confused and put together to really make something of it. And so this is where, look, you can use these tools to help generate and get you a stack of documents, but you still need those researchers to be able to, those facts people to actually tease out the insights. But one good thing was I was able to tell my buddy, hey, I know you're trying to figure this out. I want you to go check out Frosty's, because Frosty's has done a good job building a generative app and showing you all the steps that's involved in doing this. Now at Frosty's, I had a friend that was working on an application to go from natural language to answers. And the way this works was you take a question, like how many orders do I have in each state? We pass that through a large language model where we turn that into SQL. And then we can use that SQL to be able to get an answer. This is also a very common application we're getting with large language models, where we want to answer these questions using a text to SQL approach. So let's talk about kind of how she solved and build this generative AI app to solve this problem. The first issue she ran into was, as she was building the model, how do you evaluate all the SQL queries? So imagine taking this query here, show me the total population of each state, and we want to order them from the northern to the most southern one. Now, when you solve this type of problem, you'll take a query like this and have a gold standard. This is exactly what the SQL should look like. And you can see that here. Now, the text to SQL models is going to generate SQL. Sometimes it's going to be an exact match, one for one. But what do you do if it's not an exact match? Take a look at this example where it's added an extra column. And the column here is the latitude of the state. So it's just telling us how northern it is. This is an example of how lots of modern models are designed to be helpful. It's just being helpful. It's giving us extra information, but in this case, it's different. It's not the gold standard. Now, many of you probably took math, physics. You remember that some of your teachers or professors would give you partial credit. If you showed you knew how to think through the problem and solve it, you could get that. Well, this is where my friend was like, we really need to have a way to give partial credit because this is very close to the answer and I want an approach to recognize this. Now, to do all this evaluation, she couldn't have humans just look at this and grade this. So she thought about it and went with model-based evaluation, where instead of humans to evaluate it, we're going to use a large language model to do this. Now, immediately at this point, some of you are probably like, whoa, is that going to work? I mean, that's like the fox guarding the hen house. Isn't this like model collapse? How can you have models evaluating models? Just crazy stuff. Don't worry. Let me show you. So this is what an example of one of the model-based evaluation prompts look like. We ask a large language model to pretend to be an evaluator. Hey, you're a data quality analyst, or you're an analyst looking at data quality. You're going to then grade out these the text, the SQL that comes in, and we give it a grading scale with what's a perfect score, what's incomplete, what's a miss. We tell it what data is going to come in. And with this, the model can start helping us make these decisions. So let me walk you through an example of this. So here we'll see what the user query is. What are the 100 track IDs? We see the gold standard, like what exactly it should be. But here you can see our candidate SQL missed. It was a little bit off. Of course, when we asked the question, we didn't tell it how Texas was spelled inside the database. So it's a natural mistake here to confuse TX and Texas for these, because in the US they stand for the same thing. But if we go with the strict criteria of that exact match, we don't get an exact match here. However, if we go with that model-based approach and we're a little bit looser with this, we'll see that, okay, this answer isn't 100% perfect, but you know what? It captures the user's intent. The user could easily fix this, or we could fix this in post-processing to the right abbreviation as well. This model-based evaluation is very popular. One of the things you want to do is to make sure that this evaluation process lines up with other evaluation processes you're using. Here, my friend checked and she saw that 80% were the exact same when she scored them. The other 20% were within 1 or 2 when she scored them, so she felt very confident in using model-based evaluation. And her results were very similar to what I've seen in many other studies. I got tired of adding research sites here, where universally we see that often in many contexts that these large language models correlate about 80% of the time to humans in this. So this is why everybody's using model-based evaluation like that. So at this point, this was the first step for my friend. She built that model. She built out her own internal enterprise benchmark. That's another important step. You can't trust those public data sets that are out there. They're far too easy. You want something that reflects the data inside your organization. Takes a bunch more work to create that, but it pays off in the long run. So she tested it on that, only got 33%. Not the happiest about that. But she thought about it and she was like, one thing is, as I was building this, I noticed that there's a number of different text to SQL models. And each of these models had their strengths and weaknesses. Why don't I combine them? After all, in traditional machine learning, we often ensemble models that are diverse to improve our predictions. Well, what she did was she decided to try the same thing here. And she found out she got a boost in performance by combining multiple models. Now, these models would sometimes make mistakes. So her next idea was, when they make a mistake, I'm going to make them sit and think about it. Now, some of you are probably like, what? Think about it. Actually, the way these large language models work is when a model makes a mistake, if you ask it to reflect upon it, if you ask it to think about it in a step-by-step way, that actually makes the model spend more time thinking about it, generating more data, and actually they can use all of that to get a better answer at the end. So it's crazy as it sounds, it's actually widely used. Later we'll talk about chain of thought and some of the latest advances there. But it's not a surprise that this approach works and can give you a boost in performance as well. Now at this point, my friend, she'd squeezed as much as she could out of the models. So the next thing she thought about was, how about I can improve the data going into the models? Because she spent a lot of time when working on this. You actually have to look at what users are typing in. She noticed that a lot of what the users were typing in just didn't make sense. Like some of the questions they were asking weren't even SQL related, not even related to the app. They were also asking other questions that were really ambiguous, where maybe they asked for the top products, but they got to specify what products. Frosty's has a lot of products. And so what she decided to do was add a screening layer where when people asked something that wasn't relevant or was ambiguous, that she was going to take that, give the feedback to the user and let them know, hey, your question isn't worded great. Let me give you some examples of how you could word it like that and take that ambiguity, take that vagueness out so she had better quality responses coming in. And by doing that, she was able to continue to improve the performance of her model. And this was great, another step forward. But then she thought about all that data that was coming in, and she noticed that the questions all didn't ask the same type. There was different types of questions. Sometimes they were related to time series, sometimes they were like ranking things. And so just like when we go to cook, we have lots of ingredients or data or features. Similarly here, where if I'm cooking macaroni and cheese, I need different ingredients than if I'm making tacos. Same thing. If you're building data sets and features for time series, you need different data than for a ranking problem. So what she decided to do was look at those types of problems and then extract the best features for a specific problem. So she built this feature extraction layer that ended up giving her a bit of a boost. But at this point, like 75%, she was pretty happy with it, but her stakeholders had told her really they want 85-90% before they have this out there like that. So she was really trying to figure it out because she squeezed everything she could out of the models. She squeezed everything out of the data. She spent a lot of time going through that evaluation, looking at that data, and she realized, you know what? There's no way we're going to be able to solve this the way it is. That the underlying data that we have, the schemas, the databases, the tables, they're just really messy and not organized in our company. So what she decided to do is, let's call in the experts. Let's bring in the expertise. And we're going to use the expertise where we're going to create an additional semantic layer. And that's going to give us details of the data structure in a way that deals with all this confusing structure, but also puts it in the words of our business users. So when they ask questions, our language model can quickly translate between the two. So the semantic layer was a bit more work to put together, but once she got that added on, she was able to boost performance of her model. And I should point out that the semantic layer, like all the text-to-SQL answers, are doing that. You can do it without a semantic layer. If your data sets are cleaned, easy to use, it works great. If you're in a world of messiness, it doesn't, which is why many of the other providers also do such a semantic layer. So this is what the final application looks like. And there's a couple lessons here. One is I want everyone to understand that generative AI is not about a data scientist sitting out on an island by themselves, messing around with hyperparameters. That's not what's going to give you a finished application. Instead, it's building a system like this, a system that takes step-by-step work to do, a system that takes many people within the organization to do. You need experts that build the semantic layer. You need data analysts that are asking the questions. You need evaluators to run this through. You need technical people to build the pipelines, to be able to build ensembles. Something like this touches a lot of people to actually get into production at a high quality to do. Now, some of you will probably be like, hey, look, well, what is this guy talking about? He doesn't know what he's talking about. I've seen the latest advances. Like OpenAI is coming out with new stuff. We know Google's got a bunch coming. The future is you're just going to be able to just take all your data, cram it into one thing. It's just going to solve it all for you. Now, this is where, so far we've talked a lot about retrieving information. This is getting into like how well these models are able to reason and plan. How well, when we give them a ton of information, can they figure out like, hey, how should I set up how to analyze this? And so when we get to these planning areas, folks in academia have been working on it for a while. There's benchmarks out there. And so this is one of the benchmarks that's used for assessing how well models can plan. And so this is called Block World. And we're going to use it because it helps us understand where we are with our models in this ability to plan and reason. Now with Block World, we have a bunch of blocks. We put them out here in kind of a random pattern, and we ask it to stack it into a particular configuration. And as you can see, and I'll kind of play the video as I go through this, is it's not just one step to do this. Often what we have to do is you have to logically think and plan for maybe 5, 6, 10, even 20 steps to be able to solve it. And many times it's not always advancing every step. Sometimes you have to take care of a bunch of other steps before you can leap over and get everything together. And so this is how it measures that ability to think about subtasks, to think about planning like that. So when we take this type of block world and we ask GPT-4, which is the leading model when this study was initially done, you'll see it does okay, 34%. Like think like humans, like 90-ish% like that. All right, so the researchers were like, okay, well let's change it up a little bit. We're going to use a little Shakespeare to guide us. Now, Shakespeare says, a rose by any other name would smell as sweet. What happens if we rename the blocks? If I name the blocks something else? Now, renaming the blocks shouldn't change the design of the problem. You still have to think through and stack and unstack and think through the steps, right? Like what you call them doesn't matter. But for a large language model, what you does call them matters a lot. You'll see these models utterly go away with this, which tells us that that initial block world, it's just that hallucination. It's just that LLM just wanting to talk that's getting us to that 34%. It's not really understanding the task of planning like that. Now, I did a video like this probably about 2 weeks ago. This is where I left it. So just this week, the researchers went ahead and gave us the performance of OpenAI's new O1 model and how that does. Now, the O1 model spends a lot more time thinking about what it's doing. It's that chain of thought on steroids with reinforcement learning. The bottom line is, although it spends a lot more time on inference, it's better able to solve these planning problems. You can see on Block World, it does really well. On Mystery World, it's quite a bit in advance over the previous results on Mystery World. Now, sometimes what happens is these benchmarks have been out there for a while. It's very easy to either accidentally or maybe purposely train on those, and so that can affect the performance of these models. You can overfit. So what the researchers did was actually recreate Mystery World, a new randomized version, and the model still got about 37%. So a clear kind of improvement over the state of the art in a very hard benchmark. So it's not there yet, but there is solid progress. And what I'm thinking and what I want everybody to be aware of, just like we saw with hallucinations, with the issues with the legal research, now this is going to happen in the reasoning and planning area, where we're going to get models that approximate reasoning. They've seen so much material, they have some sense of how to reason. They don't exactly go through the steps, but they can make us feel like they're doing it. And this approximate reasoning is also going to suffer from lots of mistakes and hallucinations. But here's the thing is, just like on the retrieval side, where you had to be a legal expert to do it, you're going to have an expert to be able to tell when these models are going off the rails in reasoning, because the baseline for these models is so good. They're at that human level like that. So this is a warning to us, is Don't just let your intuition, what you think in your gut, look at a result and think at it. You're going to have to bring in experts and really trust experts at these points, because that's just how good these models are. We should celebrate it, but also recognize this piece. All right. Thank you all. This has been great. Hopefully these 2 use cases have given you a little sense of generative AI. I've covered a lot of significant concepts that we talk about in generative AI with hallucinations, retrieval augmented generation, reasoning, valuation, model as a judge, chain of thought, how you modularize your Gen AI development, data enrichment, all these pieces here like that. So what I want to make sure everyone takes away from this is recognize, first of all, it's a project like any others. It's going to touch many people within the organization. These things often don't go as planned as when you're putting them together, but it often takes that system, a group of people, to build something useful like that. All right. Thank you all.